Welcome to the Explainer. Every time you tap on a link or open an app, there's this whole hidden world buzzing with activity just to keep things running. Today, we're going to dive into that world with the tale of two very different requests, one friendly, one malicious, and the invisible guardians that can tell them apart.
Okay, so let's get into it. You see that your favorite website is online. But does that actually mean it's healthy? It's a great question, right? See, there's a big difference. And to understand it, we've got to meet the hero of our story, the web server.
So, just what is a web server? Well, picture it like this. It's a tireless digital worker. Seriously, it's the engine that powers pretty much everything you see on the internet. It's constantly juggling requests from all over the globe, serving up articles, videos, all that good stuff right to your screen. And as you can imagine, that's a really demanding job, and sometimes things can go wrong.
And hey, like any hard worker, that server needs a checkup every now and then, right? To make sure it's not about to burn out. This brings us to the first character in our little drama, a friendly visitor, and its only job is to ask one simple but super important question.
So, this friendly visitor, in the tech world, we call this a health check. And honestly, in today's world of complex apps, where you've got all these little services trying to talk to each other, this simple, hey, you okay check, it's absolutely crucial. It's how you know the whole system is actually working together. But how does a health check actually work? Well, it uses something called a health controller. The easiest way to think about it is like a special doorway or an endpoint on the server. Its only reason for existing is to answer that one question. So when a monitoring service comes knocking, a healthy server just gives a quick, simple, yep, I'm okay. It's literally like taking the server's pulse.
And the real genius here is just how simple and efficient it is. The request goes to a special address that's built to do nothing but respond. That means the whole checkup is incredibly fast, super lightweight. It doesn't get in the way of real people trying to use the site. It just confirms the server is alive and ticking without causing any extra work. Simple, right?
And that's why it's so powerful. Think about it. That constant stream of OK messages gives developers real-time feedback. If those OKs ever stop coming, bam, they get an alert instantly. And a lot of the time, they can fix the problem long before you or I would ever even notice something was wrong.
Okay, so that's our friendly visitor. But as you've probably guessed, not all visitors are so nice. Some are designed to cause chaos. And this is where the villain of our story creeps onto the scene.
And this villain has a name, the malicious slow request. Now, this is a sneaky kind of attack. The whole point is to send a request that's programmed to take a really, really long time to process. If an attacker sends a whole bunch of these, they can tie up all the server's resources, basically grinding the whole website to a halt for everyone else.
So to see this in action, the developer in our source material actually set up a little experiment. They built a special endpoint on their server that, when you hit it, intentionally kicks off a slow, painful process, one that's designed to last for a full 70 seconds. But here's the thing. Our server, it has rules. It has a line in the sand. To protect itself from exactly this kind of thing, it has a strict patience limit. No single request, none, is allowed to take more than 60 seconds. Anything that goes over that limit is automatically seen as suspicious and maybe even dangerous. And just like that, we have a showdown. The malicious request is designed to take 70 seconds, but the server's hard limit is 60. This isn't an accident. It's an intentional attack, built to break the rules and cause a major disruption. So that's the million-dollar question, isn't it? How do we stop this slow-moving request from hogging our server for a whole 70 seconds? Well, this is where our final character makes their grand entrance, an invisible guardian standing watch at the server's gate.
In the dev world, we call this guardian middleware. And a great way to picture it is like a security guard or maybe a bouncer for the server. Its one and only job is to check every single request that comes in the door and enforce the house rules before that request can cause any trouble. So, how does this bouncer do its job? It's pretty cool, actually. For every single request that arrives, the timeout middleware starts a stopwatch. And if that request is still running when the 60-second alarm goes off, the middleware immediately jumps in.
All right, let's watch this guardian go to work. The slow 70-second request shows up. The middleware says, okay, you've got 60 seconds, and starts the clock. The second that timer hits 60, the middleware doesn't even hesitate. It just cuts the connection, throws the slow request out, and sends back an error message. And just like that, the server is free again to help out the legitimate users.
And we know it worked. The test shows it perfectly. Instead of getting stuck and slowing down, the server correctly sends back a 408 request timeout error. The attack was a total failure. Our Guardian did its job and protected the system.
So, let's step back. What's the story we've just told? We've seen two totally different visitors, one friendly, one malicious. And by getting ready for both of them, we've basically built two essential pillars for making a stronger, more reliable, and way more secure service.
It really boils down to this. On one side, you've got the health check. Its job is to constantly ask, hey, you still running? That gives us a real-time pulse on the system. And on the other side, you've got the timeout middleware. It's the protector, kicking out any request that stays too long. One gives you eyes, the other gives you a shield.
And this is what you should really take away from all this. These aren't just fancy bits of code. The health check gives us what we call observability, the power to actually see what's going on inside. And the timeout gives us resilience, the ability to bounce back from an attack. You put those two together, and you've got the foundation for any application that's built to last.
And that kind of leaves us with one last thing to think about. We just looked at two of these invisible guardians, but honestly, they're just part of a much bigger unseen army. You know, firewalls, rate limiters, encryption, all working 24/7 to keep our digital world from falling apart. It really makes you wonder, doesn't it? What other guardians are out there, right now, protecting you online?